Here's another example of a pH of a buffer system type problem. What is the pH of a solution that results from adding 0.25 moles of a strong base, sodium hydroxide, to a weak acid, 25 mils of 0.1 molar lactic acid? Notice that the concentration of the sodium hydroxide is less, so we have a little bit of an excess of lactic acid. They give you the Ka of lactic acid. I always appreciate that. You don't have to look it up. And we need to find the pH. A couple things you should recognize from this problem. Number one, is it a buffer system? In fact, it is, but it's one of these where you're going to make a buffer by the chemical reaction. So you have to figure out, just do some simple stoichiometry at first, to figure out what's in the flask, realize that they've created a buffer system, and then find out the pH. And whenever I see what is the pH of a buffer system, I like to use the Henderson-Hasselbalch equation. I'll also show you a normalized table method of solving it. So we have to figure out what's going on. We have to write down the chemical reaction first, and the chemical reaction is lactic acid, which I'll abbreviate as HL, reacting with less than an equivalent of a strong base to make some water, which is in the liquid form, which we'll ignore from the equilibrium expression, along with sodium lactate. That's the weak base, so if we have the conjugate or weak base of that weak acid, we will have a buffer system, and in fact we will. So how much lactic acid is present after it initially? Well, 0.025 liters, and it's 0.1 molar, right? This is lactic acid right there, sure. It means that's how many moles of lactic acid we have. How many moles of sodium hydroxide we have? Similar analysis. We have 0.025 liters, but it's only 0.05 molar, so we have that much less sodium hydroxide. This cannot possibly make more than 0.00125 sodium lactate, because the rest of the lactic acid, which will be the same amount, right? Isn't this half of it? Will be excess. Stating that in words, the reaction of, I wrote it in 25 milli, I wrote it in millimoles. You could also just simply say it in moles. You'll get the same answer, but the reaction of 25 millimoles of lactic acid with 12.5 millimoles of sodium hydroxide has got to make 12.5 millimoles of sodium lactate and no more, because at that point you're out of sodium hydroxide, and you'll have 12.5 millimoles of lactic acid remaining. Note that if they had used excess of sodium hydroxide, you wouldn't even have a buffer system, because you'd have some strong base reacting, and you would not even, that dissociates completely and would dominate the situation. But we don't, so they've made a buffer system. That's wonderful. I would then directly go to the Henderson-Hasselbalch equation, except note that we only have moles here. We need concentrations if we're going to solve for it. So the concentration for everything will be just divided by the liters of solution, and it looks like we have 50 milliliters or 0.05 liters. Since there's 50 milliliters of solution, we can get the concentration of each as being 0.025 molar. So we have our buffer system. It's 0.025 molar in both lactic acid and sodium lactate. We have the Ka. Let's plug in using the Henderson-Hasselbalch equation. We write it down. The negative log of that number is the first part. The log of 1, in this case, would be the second part. And we get a pH of 3.85. I love the brevity of that. But perhaps you prefer a nice table, so let's go ahead and do that. We're dissociating lactic acid at this point, and we know a lot of things. We know 2 of the 3. We know that it's 0.025 molar for both this and this, but we don't know that. When it reacts, this will go down a little bit. Each of these will go up by the same amount, but we're going to ignore 2 of those 3 things when we add our, because they're small. After all, this is a very low Ka value. And when we solve it, we're going to get the same answer, right? We have everything except H+. So we solve for X. We find out that the pH is the same. I hope you can see that the Henderson-Hasselbalch equation is, in my opinion, a faster way to solve it. But there it is shown either way.